Okay. Metal rod, the length of the rod normally distributed with the mean 25.2 centimeter, standard deviation 0.4 centimeter. Let me illustrate that with the bell curve. It's not perfectly symmetrical, but good enough, right? Okay, the mean is the peak of the bell curve, okay, which is 25.2. 25.2. The mean, mu, and standard deviation is 0.4. So the next value when you add 25.2 and 0.4 is 25.6, which is very small, but it occupies about 34%. Remember that, So 34% is something like this. And the next value here is 25.6, one situation around the mean. How many rods in this sample? The sample consists of 500 rods. Okay, the 500 number here is called the sample size, the number of values of items in a sample. This is one standard deviation. The standard deviation again is 0.6, 0.4 here. It denoted by sigma letter. Okay. Within 0.5 centimeter around the mean. 0.5 is a little bit greater than 0.4, 0.5, just slightly greater than 0.4. So the rod with the length within 0.5 centimeter from the mean. When you add 25.2 with 0.5, 0.5, you get 25.7, which is here. This point is 25.7. Similarly, you need to do the subtraction. 25.2 minus 0.5. Okay, you get 24.12 minus 5.7, this position is 24.7, so you need to calculate the probability that the rod is within this region. Calculate the probability that the length of the rod, this letter represents the length. The length is smaller than 25.7 and greater than 24.7. Okay, within this range. And yeah, so the next step, you need to calculate the 2 z-score. The z-score of 25.7 is 25.7 minus the mean. Actually, it's 0.5 within the mean, but I'm writing this formula to remind you about the formula that we use to calculate the z-score. 25.2. Again, this difference is 0.5. Okay, the standard deviation at the bottom is 0.4. 0.5 over 0.4, which means 1.25. Okay, and similarly, the z-score of 24.7 is 24.7 minus 25.2, which is the mean, divided by standard deviation 0.4. It is negative 0.5 over 0.4, and therefore it is negative 1.25. Okay, so we have the 2 z-score. However, the formula sheet here, MF19, it does not allow you to calculate the middle region here, the red region, directly. Impossible to do that directly. We have to do it indirectly, by calculating this area. And the area here on the right is also the same because of the symmetry of the bell curve, symmetry of the distribution curve here. So this green region has the same area with this green region on the right. Okay, I can calculate the whole, let me use the pen. I can calculate the whole area here using the MF19 formula sheet, the whole area here, using the z-score, the upper z-score, which this one. Okay, let me denote that with a different color. I will use the z-score here, 1.25, which is here, 1.25 here. Again, I will calculate this whole area. Okay, so that I take 100% and subtract that whole area, I will get the green area here on the right. Okay, I'm calculating the area on the left, which is the probability that the height, the length of the tree is smaller than 25.7 is the same with the probability that the z-score is smaller than 1.25. Okay, here the MF19 locate 1.25, 1.2 here, 1.2, and then number 5, let's use the black color, 1.2 is here, and then 1.25 is here, exactly this value. So we do not need to know any other thing behind, okay, just exactly this value. This is the answer, 0.8944. okay, it is 0.8944, right? I'll check the thing again. The value 0.8944 that I've just got again is a whole area here on the left. Okay, and now I'll take 100%, subtract that value to get the area of the green color region here, okay, which means the probability of the length greater than 25.7 is 100% minus 0.8944. You calculator, 1 minus 0.8944. We have 0.1056, 0.1056, okay, which is the area, which is also it equal to the probability that the z-score is greater than 1.25, the region on the right, okay. Similarly, this is equal to the probability that z is smaller than negative 1.25, there. The probability that the length of the tree is smaller than 25.7 and greater than 24.7 is the region on the at the middle here, 0.8944 minus the 0.1056. I am calculating this whole area, the big area here, which is 0.8944, and then I subtract this one, which is 0.1056, okay, to get the middle, the red region. The red region here is almost the answer, okay. You got it, right? Can you say again? 7 point something? 838. Don't we have? Okay, but anyway, okay. So this is the probability, the red region. So let me change that into the red color. This one, red color. And then the last thing, the number of tree that we need to answer, so that the length of those tree is greater than 24.7 meter, or and smaller than 25.7. Is it meter? Because a tree cannot be that long, centimeter. Yeah, just a small. Oh, sorry, it's not that. Not tree. Metal rods. Metal rods. Okay, 25.7 centimeter. The number is this probability 0.7888 multiplied with the sample size 500. This is the answer. 394. Here, you see. They can even round it up because it is slightly greater, 0.4. So there are two answers. Any of them, is fine, 394 or 395. They are both accepted in the mark scheme.